I'm very excited because we are going to move forward with our next keynote of the day. The keynote is going to be delivered by Johannes Hoffart from Goldman Sachs's R&D AI team. I was going to actually read you Johannes's bio, but in the interest of time, I'll cut it short. Suffice it to say that I'm pretty sure at least a few people on the call have used a knowledge base named Yago or an entity linkage system named IDA in the past. Both of them were co-created by Johannes, and he's also a senior research scientist at the Goldman Sachs R&D AI group and has also co-founded a few businesses as well. So we're very excited to have you here, Johannes. You should be able to share your screen.
Awesome. Great. Thanks for the introduction. Thanks for the invitation. I'm really excited to be here and present some ideas on rich text and lean knowledge bases and kind of our experiences and outlook on knowledge extraction from financial documents. Brief disclaimer up front. So this talk is built on joint work with many colleagues of mine at Goldman Sachs. However, of course, I remain responsible for views and opinions expressed here. They are not necessarily shared by my employer or my colleagues and are for informational purposes only, and examples are public documents or made up. So with that being out of the way, let's focus on the interesting pieces of the talk. Let me start broadly with the research vision that we have in the AI group. It's really heavily focused currently around knowledge extraction from documents, and really understanding how language and document structure conveys meaning. This also means that, of course, we want to extract structured knowledge from the documents, create a knowledge base from that, and also connect this knowledge to existing knowledge sources, and in the long run, enable knowledge-driven processes and applications. So you've heard in the intro, like the Yago knowledge base, the AIDA system. So I think that my research agenda that I had before is really very well captured here in this idea of using information extraction methods basically to construct knowledge bases. There are, of course, several key differences to the more, I would say, work focused on the regular information extraction to the financial domain. This is really what I want to cover here in this presentation, in this keynote, starting with extra dimensions that we find in financial documents that help us to inform extraction, but also make it sometimes difficult. Then one key use case that we can achieve when we have this, when we can deal with these extra dimensions, which is executable credit agreements. So this is a long-term research goal. And finally, how this all is related to entity linking the financial domain and how we can actually make progress there. So let me start with the extra dimensions in financial documents. Before I want to start with really what makes the documents different, let me first actually start with giving you a very brief overview of why it's actually valuable to deal with these documents, right? So there are so many use cases that we can address when we understand the content and the knowledge that is captured in documents. And I want to give you a brief spotlight here. So for example, in valuation, to automatically derive valuation signals from diverse documents like financial statement, analyst reports, or news. Regarding risk, to use knowledge extraction to pre-identify events that could pose a risk to individual market participants or the market as a whole. In the operations space, of course, there's a lot of repetitive information extraction tasks there that could be supported to be done more quickly. In the area of sales, maybe using knowledge about texts, knowledge gathered from texts to identify opportunities automatically, and then using also natural language understanding, natural language generation techniques to tailor offers to clients' needs. And this is really just a snapshot. I think there are many, many more valuable use cases that you can cover when you really are able to extract knowledge from financial documents. One research challenge that will then lead to this executable credit agreements is definitely the credit agreement document type. If we look at that, how we can add value just by extracting knowledge from the credit agreements and understanding them, we could combine them with financial data and prepare accurate data for the valuation process. So given this credit agreement, given the current financial status of a company, what is this credit agreement worth? Can we maybe trade it? From the perspective of risk, sometimes lawyers try to get very nifty and put loopholes in the contracts, having like circular references between definitions of terms would be awesome to be able to detect this automatically in these credit agreements. Operations, of course, we need to ensure that the covenants that are specified in the credit agreements are really upheld. So from an operations perspective, this could be automated. And from a sales perspective, you could think of automatically creating credit agreements, just like many consumer-oriented banks are doing it with mortgages, automatically creating credit agreements to mid-sized businesses. So you see, like, even from a single document type, you can derive so much value if you really understand what's going on in there. And it's by far not the only document type. So there are many more documents that we actually can have a look at that make up the financial space. So contracts and reports and financial statements and prospectus documents and filings. And I mean, the list goes on, and you could almost say that finance basically runs on documents and not really on numbers, right? There is a lot of truth to it, I guess. Interesting, like technical issue, most of these are PDF. And I think this is also where we really want to dive deep. Why are these all PDF, right? So why is it not just text? The key reason is that financial documents are really rich text. So you need to understand the structure, the visual structure of a document to be able to understand what is really expressed. So here in this case of this ISDA master agreement, the fact that the Bank of America and LKQ Corporation are the counterparties, this is something you get very easily as a human just looking at the document without reading anything, right? This is a visual structure that is adding an extra dimension to the document. The content is often deeply hierarchical. So it's nested sections, subsections, paragraphs. In the paragraphs, you have nestings. So it's really not just running text, it's a hierarchical structure in the text itself. There are many of these kind of terms that are uppercased or section references, right, which are basically hyperlinks for humans. They're not clickable in the traditional sense of the web hyperlinks, but they're definitely conceptual hyperlinks. So you as a human can go and look them up and actually get their definition and their meaning. Last but not least, there's the text has a temporal nature, meaning that the texts are dated as of a certain time, which plays a role when you do information extraction. Let's have a bit of a closer look. The visual structure we have already seen. This is definitely formatted to preserve layout. That's why you need PDF. It's full of boxes and tables. This is really an important factor when extracting information. The deeply hierarchical content. Let me actually briefly read this example. This is an example that will be recurring over time. This is saying the indebtedness of the borrower and or any restricted subsidiary in an aggregate outstanding principal amount at any time outstanding not to exceed the greater of X $100 million, Y 11.5% of consolidated total assets, determine the time of occurrence, and Z the lesser of 45% of consolidated adjusted EBITDA for the most recent 4 fiscal quarter period and 200 million. Key point here, the X, Y, and Z, and the nesting structure that is basically made explicit by the lawyers writing this text because they saw this is a really complex sentence and we really want to make sure that the mathematical formula that is actually expressed here is easily understandable. The third dimension, hyperlinks for humans. This is not just some random one-off thing that you find in one single sentence. If you look at this paragraph, liens person to any loan document, liens, swing line lender, LC issuer to cash collateralized. So basically every other word is either a defined term or a section reference, right? So you really want to get this, to make use of this contextual information that you can get from there. And temporal text doesn't only mean that the document is dated as of a certain point in time. It also means that it's sometimes heavily redlined and edited, and you want to be able to deal with that. And this is not just an example of like some document that is in an intermediate state. This is actually a credit agreement posted to the SEC filings, right? So this is a real life credit agreement. And across all of this, the key insight that everything is kind of English language. Lawyers don't like writing mathematical formulas. And basically you have constraints, logical expressions, statistical observations, something like SQL queries basically in all these documents, right? and you want to be able to extract that back. If you manage to do all that, you can get to many interesting solutions. One that I think is that I want to highlight here, which makes a lot of use of one of the extra dimensions, which is deeply nested structures, is executable credit agreements. So these extra dimensions aren't just burdensome and just something that we need to deal with. We can actually make use of them to inform information extraction algorithms. So credit agreements, if we automatically understand them, one of the goals is really to look at, so I'm not expecting you to read this, right? It's just an example here. One of the key pieces of a credit agreement from a risk perspective, from an operations perspective, are the negative covenants. What is the borrower not allowed to do, right? So they constrain financial values. This is the incremental debt that the borrower can take on, or this is what happens if the borrower does something like doing an IPO or being acquired. So all of this is captured in the negative covenants. These sections are sometimes so long that if you really want to read them because, hey, something has gone wrong with our borrower, we really need to see if our covenants are addressing this case. This sometimes can take hours, right? So you want to really make sure that you have this at the ready when you need it. So the goal really being that you can extract machine readable constraints and triggers from these mathematical formulas. All right, so we've seen this example before. This is, I think, a pretty standard example of one of the terms in the negative covenant section of a credit agreement. Again, to repeat, the key extra dimension we want to make use of are these little labels here, the X, the Y, and the Z, which are there for a reason. They basically tell you that, hey, if you want to understand this as a nested structure, these three things are siblings. Essentially, we want to get to a representation like this, really a machine readable term of this credit agreement where all of the variations, all of the information expressed is normalized and canonicalized and can be both easily understood by a human being, but also be executed. So the incremental debt, actually as a reference, here's the original term, the incremental debt, which is indebtedness of the borrower or any restricted subsidiary, must be less than or equal to, so this is not to exceed, the greater of, and then you have X, Y, and Z, 100 million, 11.5% of the assets, the lesser of 200 million, and 45%. So note that you cannot completely rely on these labels. So here, the lawyer decided that, hey, this is easy enough to understand that we don't need sub-labels here. This can happen, this doesn't need to happen. So you basically need to be aware of that when extracting the hierarchical structure. So how can you go about that? Interestingly, the nature of the extraction that you want to achieve can actually be tailored to the knowledge that you want to extract. So in this case, even though this looks horribly complex, the individual elements are actually not that hard to extract, especially starting with the relations and the operators. Interestingly, that's like if you look at the general information extraction at something like ACL or AAAI conferences, right? Often relation extraction is super hard because there's so much variation, there are so many different relations. Here, because they are mathematical in nature, this actually means that you can just really explicitly enumerate all the possible operators and relations and all the variations. So you can do a simple dictionary matching to get to these elements. The governors, are basically the variables that are constraining something. Again, not too many. Most of them are defined terms, not so hard to extract them. You can sit down with a business expert, you can enumerate them, or you can even try to extract them from the defined term section. The objects, which are like just the numbers, either the percentages or fractions for the governors or really absolute numerical dollar values, regular expressions are good enough. Temporal expressions, it's a very specific subproblem that I don't want to really get into here, but also I think that can be solved because there's a very kind of limited space of extraction again. Harder problem is provision and the type. So type being the full type, the classification of this full term. There's a lot of variation in the provision and the type statements. However, there is again a clear structure in the term. So usually the provision, which is the kind of financial figure that is constrained, so this is the incremental debt that must not exceed, right, is usually on the left-hand side of this term and on the left-hand side of the relation, right? And I mean, it's always on that side actually, and usually this also means it is in the text to the left-hand side of the relation. So this is something you can make use of and maybe just use a simple trained classifier on top of the left-hand side text plus the context of the title stack, for example, the fact that this is part of the covenant section and the limitation of incurrence of indebtedness section. If you feed all this into a classifier and you have your labeled set of target provisions, this also works quite well. So given the elements, now you want to make sure that you also understand the term structure, right? So you want to get something like this out of the term to be able to connect all the variables and the numericals together in the right order. Structure, I've alluded to this. There is a mathematical constraint that we're extracting. So operators, the red pieces, can only connect to, on the left-hand side, the relations, and on the right-hand side, the objects, the numbers, and the numbers can also only connect directly to the relations or to the operators. So limited space for the structure, doing a supervised classification on top of this, and with limited training data, you can really very easily extract that. One key thing that you want to make use of course, is the structure that is given to you, this XYZ, which is basically the inline structure of the paragraph that should feed into the whole problem as features. And the last step is canonicalizing the individual elements that you have recovered. For that, creating a knowledge base that classifies the individual terms is very useful. In the end, you definitely do not want to have variation in these terms because otherwise you cannot execute them, right? So the knowledge base really gives you the crucial background information, what to link to. And if you combine all these bits and pieces, you really come up with a machine readable term. So not to say that this problem is solved, right? This is really like a research goal that is hard to achieve, even though I've kind of said that some of the parts are easy. To really get this correctly done for each of the negative covenant terms in each credit agreement, a lot of work needs to be done. But the fact that these documents are really rich and there's visual structure and that you have defined terms as hyperlinks there gives you a handle to get started with that. Also, you don't really need to understand the full structure of these terms in order to be able to provide value to business users. So for example, here, what I'm showing to you is like a semantic search on top of extracted terms, where you can search for all of these terms across different credit agreements. So give me all terms in any credit agreement where the provision equals capital lease and purchase money debt, right? So you can really think of that as a type ahead search and results being displayed in a tabular manner so that you can very easily compare the terms in different credit agreements, which is something that is very valuable when you're drafting new credit agreements or you're new to the business and want to understand what are the other credit agreements that we have already in place. Like you want to drill this down by like other dimensions that come from other knowledge sources, like which country is the borrower from, which industry sector is this borrower from, and you have a very powerful search capability on top of something that is currently, I would say in most cases, looked at through Adobe PDF and searched through by pressing Control F and really searching for individual strings in a document. So there's a huge gap that you can achieve, even if you don't fully understand the terms. A crucial piece here that I want to emphasize again is that you need to have a canonicalized version of these terms, right? So capital lease and purchase money debt is expressed in a variety of ways in these documents. Same with the type of indebtedness. That's actually something that you need to canonicalize to be able to search for that. So entity linking or concept linking is really central to all the information extraction tasks also in the financial domain. And I want to, in this kind of third part of the presentation now, highlight some issues that I think need to resolve if we really want to solve or address entity linking in the financial domain. For those of you who don't know entity linking, a very brief introduction. Entity linking is the task of, so we've seen it before, right? We're like normalizing the terms, but I want to also introduce this in a general way. It's really the task of understanding which names are there in a certain text, like GS appointed Gibson as co-head of global TMT banking. Gibson as a name, it's very ambiguous, right? Could be many things. So first you want to see that Gibson is really a name. And the second part is identifying Gibson as some very specific entity in a knowledge base, and knowledge base here being something that could be very broadly understood as, for example, LinkedIn, right? You want to link to the URL of Matt Gibson in LinkedIn. Key problem here is ambiguity. The same word Gibson in the sentence Jake described playing as Gibson as transcending moment has a completely different meaning, right? And also probably a completely different target knowledge base that you want to link to. So here we could solve entity linking, the entity linking problem for this sentence by linking, for example, to the Wikipedia URL for Gibson, the guitar manufacturer. The terminology, just briefly, entity linking is usually seen as a two-step process where the first step is entity recognition and the second step is entity disambiguation. So recognition, like where in this text is it mentioned? What is the spot? What is the occurrence of the name in the text? Disambiguation is like which entity is the canonical identifier for this. Let me give you a brief history of entity disambiguation over the years. So this has been a topic for around 10 years, actually longer. The first works in that line were done 2006 by Bunesco and Pasca on Wikipedia, where basically the realization was that Wikipedia is such a great resource for understanding texts and the entities that are there, because you have canonical identifiers for every entity in Wikipedia. So a lot of work was done in that area. And you can see that starting 2009 with the first methods, there's really a continuous increase in accuracy of these methods, right? Starting from below 75 all the way up to last year, 95% accuracy. Given a mention, what is the correct entity? Almost solved, you could think. Interesting anecdotes. So 2013, actually the first neural architectures were already emerging and pushing entity linking accuracy to 85%. 2015, a very interesting artifact, you see that there's a huge blip from 86% to 92% accuracy. And that also highlights why entity linking is not just a methodological problem, but you need to really get your dictionaries and your knowledge bases right, and everything needs to fit together very neatly. Because actually here in this paper, the dictionary changed, like the candidate space was reduced, the ambiguity of the mentions was reduced, the problem was made easier. Hard to compare if really the method was giving the increased results, or it's due to the reduced dictionary space. If we look a bit further to the right, where the 2016 Yamada et al. And Yamada et al. With the asterisk, these two values are actually from the same paper using the same method, but different dictionaries. And there's a 1.6 F1 accuracy point difference just by using a different dictionary. 2016, deep learning methods push past 90% accuracy, and last year, using BERT and knowledge base as context, so extending the context by the knowledge base, pushes to 95%. So now you could think 95% accuracy, that's kind of a number where we usually assume that it just works well enough to be really used in practice, and we don't really need to care so much about the error rate anymore. Of course, you can always improve, but it's really like close to getting solved. So when we introduced the Conley-Argo data set. In 2011, the accuracy was 82%, the state of the art. So very hard to go from that to 95% actually. So now we want to link entities in financial documents. We've already seen one use case where we want to link like concepts, financial concepts in the credit agreement space, but there are many other cases. So for example, here, legal entities in legal documents. Who are the counterparties of credit agreements? So there are a lot of organization entities here, Duncan Finance Corp, Duncan Brands Holding Inc., Duncan Brands Incorporated, and then all the syndication agents and joint book runners and lead arrangers, the banks. So we should be able to really just use some off-the-shelf solution because Wikipedia and Wikidata contain organizations and we are done. Unfortunately, that's not really the case because for Goldman Sachs, for example, Wikipedia only contains the Goldman Sachs Group Incorporated, which is not the same legal entity as Goldman Sachs Lending Partners LLC. This might not matter to the average Wikipedia users, but we definitely know that this is not what we want to have in a legal case, that we just link randomly to other legal entities. Luckily, there are great knowledge sources for exactly this use case. The LEI database, which has unique identifiers for all participants in the financial markets. So again, we can say, now, aren't we done now? But unfortunately, we're only getting started. So first of all, the methods need to be adapted to the knowledge base. Second, you need to clarify some more questions like, are we only looking at named entities or also at concepts like credit agreements or lead arrangers, which might be important as kind of what is the role that this company is filling in this document? Should we account for name variation? Fund names are really hard because there's very little difference, but it's a different legal entity. What is even the context? So here on the front page, you see Duncan Finance Corp, but you don't see any further contextual information. You don't know if it's like a US company or if it's a company from a different country. Where do you get the context? How do you validate the linking accuracy? And last but not least, these knowledge bases, LEI, is not as broad as Wikipedia. It really covers only financial and legal entities. So we need to make sure that the linking algorithms understand when can we actually link something? When do we need to abstain? So a lot of open questions. And I think the underlying issue there, why this is why we have so many open questions and not a lot of solutions, is because that Wikipedia entity linking really assumes lean text and rich knowledge bases, whereas in specific domains it's often the opposite. So we've seen in the first two parts of the presentation that we really have rich text with lots of extra dimensions that we can use for information extraction. In entity linking, we mostly have newswire text or Wikipedia text, which is not really structured. It's really just running text. And rich text mention spans are hard to identify. The context is hard to identify. We've seen this on the title page. And interestingly, if you really dig deeper into the credit agreement, there is one part of the appendix where you really have the addresses for the entities, and you can then use that to validate if this entity is really the one that you're looking at, and not from maybe a different country. Visual cues matter, and it goes beyond named entities. So a lot of richness in the text. We have lean knowledge bases. So exactly the opposite is Wikipedia and Wikidata, which are very rich, cover a whole lot of spectrum of entities with a lot of descriptive context. Most of the in-domain knowledge bases, also LEI, you have very little context. You have a short description, you maybe have the parent subsidiary relationships, and that's about it. And besides ambiguity, which is usually looked at as the key problem in entity linking, so one name like Gibson, meaning 500 different candidates and you need to decide which one, here name variation is a huge problem. So you have probably only the canonical names, but then in text, people are people and just refer to these entities using different notation. So why is that the case? I think that in the entity linking research, in the broader sense, there are a lot of unquestioned assumptions that are really diminishing the applicability of all of this research for the financial domain, and also for actually special domains in general. So for example, for knowledge bases in text, we assume that the knowledge bases contain named entities, but not technical terms or concepts. So on the left-hand side, I'm showing the assumption. On the right-hand side, if I could find one, I want to highlight one keyword that is really addressing these assumptions, but not solving them. And usually the ratio between publications that have these assumptions to ones that try to address these assumptions is like 10 to 1, right? For every one that tries to think outside of the main established mainstream, there are 10 that just try to improve the established mainstream. So we see here for named entities, it's of course in the biomedical space. There was recently a very large corpus released by the Carl Zuckerberg Foundation, MedMentions, which really has triggered a lot of entity linking in the biomedical space. Unfortunately, I'm not aware of any corpora of significant size in the financial space, which might be linked to FIBO or REI. I might miss it. I have been searching, I have been asking, but I haven't found this, but maybe I'm missing it. If I do, please let me know. That would be awesome. Second assumption is that knowledge bases are basically static with some minor driven entity IDs. So Wikipedia URLs, right, if you take them as identifiers, they usually change like maybe 2% per year or something. But in our case, we have texts that are really anchored at a certain point in time, and we really want to make sure that the knowledge base reflects this time, and we don't want to have this drift. There's very little work that addresses this kind of drift. There is some work that says, hey, we have a temporal knowledge, temporal text. Why shouldn't we at least adjust the priors to improve the disambiguation quality? Third assumption, mentioned before, the knowledge base has rich content. So we have semantic types, attributes, and interlinkage. There's a very nice piece of work by Wu et al. Last year at EMNLP, which addresses this in a very nice way. Basically saying we can do entity linking with zero shot. We can just add new entities by their description, and it works pretty well, but definitely only a starting point. Assumption 4, texts are lean, context is just neighboring tokens. There is some work last year by Mulang et al. That tries to extend the context by using more knowledge from the knowledge base, kind of in an undisambiguated way, and extends this to jointly represent the text and the knowledge in the same way. I think there's a lot of potential there to really think about how do we represent the strings and the things in the same way so that we can do better linking. But again, it's very early work in that space that can be extended. So beyond these unquestioned assumptions for knowledge bases in text, I want to present 2 more pages of these, so bear with me, but I hope that there is something interesting for you to look at afterwards. There are more unquestioned assumptions for mentions and candidates. So for example, that the linking starts with recognizing the mentions independent of the entities. That works quite well for something like Wikipedia, where you assume that, yeah, you have everything there. But yeah, ideally, if you have something like LEI, you want to drive the recognition of the mentions in the text by what you have in the knowledge base, because that's only the only thing that you want to link. So again, there are some works addressing this. Prabhakar et al. With the Jolam paper that is to be published at a web conference later this year. Not fully addressing this like knowledge-based centric view of the world, but at least making the case for like a configurable framework of how you can plug in different components to make sure that the linking works well. Second assumption, there's no significant variation in candidate names. It's all part of a large dictionary. Again, some research being done into automatically and algorithmically creating these variations. Still some open questions remain not unaddressed, and especially also like how this can all be integrated into a larger system. And as we have seen before, the dictionary and the candidate retrieval really has a significant impact on the linking quality. So the 1.6 accuracy difference. Third assumption, there's a correct candidate for every single mention, which is not the case, right? This was really understood very early on, even 2010 at the knowledge-based population tracks. We need to understand when an entity is really not part of the knowledge base. I think this is in part an artifact of the established benchmarks, mostly being evaluated on entities that are really part of the knowledge base, mentions that have candidates. and everything else is kind of assumed as, oh, we can do this later, right? This is something that we can always do as post-processing, which I don't think is the case, right? And last but not least, there's training data for each mentioned entity pair. Well, this is true in Wikipedia, but good luck doing. And again, the zero-shot entity linking paper partially addresses this. At least you don't need training data for a new entity. You still need a lot of training data to train the models initially. So last but not least, assumption for evaluation applicability. Confidence scores are assumed to be a way to trade off precision versus recall, but not something that you need to interpret as a human being. That is, of course, in a professional domain, you want to make sure that these systems are transparent to humans. There are some calibration methods for machine learning methods in general, but not specific to entity linking. And I think you can use the knowledge base as kind of driver for understanding what confidence really means. Precision is more important than recall. I mean, most methods are really evaluated at rank 1, so you just use accuracy, but in a legal domain, you can imagine that 100% recall is actually the thing that you're going for, right? How do you get there? And kind of the other side of the coin here is like maximizing accuracy if one is the only thing that counts. There is some work addressing this and saying, no, it's also about applicability and configurability, but really the usability of methods in the real world scenarios is fully underexplored. And it's not just engineering, it's really also research, because you can't just take each of these individual components and contributions and plug them together and think that they just work. And this work by Van Halst et al. Tries to address this. And the last unquestioned assumption is that linking is done in one shot without human intervention, which is of course also not true. We all know that these models need continuous supervision, they need continuous retraining, and there's very little work on that, none that I know of in the deep learning age, basically, of how to construct knowledge bases and these models jointly. And I think a key question is really, how can we trade off expert annotation time versus linking quality? So this brings me to kind of what I think are the key open research questions for entity linking in the finance space. First, a corpus would be awesome. Again, I might have missed this, but I don't think so. So I think there really should be a shared task, or like a push for getting a corpus where, for example, SEC documents are linked to LEI and FIBO. A stronger attention to a real-world applicability of the evaluation. So don't just evaluate at accuracy, really also evaluate at recall levels that make sense for real-world use. And this is more important than F1, really. And expensive training data is expensive, so you need to have iteratively improved solutions. Evaluating after K training samples is a key measure, right? Some papers actually do that. So you have these graphs, like these are the number of training samples, this is the result. I think more of that is in order. And of course, training of model construction versus running time. So all these trade-offs, I think, are assumed to be very one-sided on just accuracy. So concrete research questions: how can we deal with this partially overlapping knowledge base phenomenon? Is confidence calibration and thresholding really the best answer? How can you combine these one-shot models that we usually only take into account the description with more knowledge from the knowledge bases? And how can we better understand, expand the context around dimensions? And I think in the interest of time, I will skip over the two starting points that I think would be interesting to explore to take this further. So one paper I've mentioned repeatedly, zero-shot entity linking, really a nice paper to get started with, which uses very little context but achieves a lot. It's very applicable. And the second one, the Mulango et al. Paper, where it does some initial exploration of how you can jointly represent text and knowledge. How can we extend this to also represent rich text? Yeah, to sum up, we have seen that in the financial domain, texts are really have some extra dimensions, are really rich in nature. We have visual structure, hierarchical content, hyperlinks for humans, and temporal text. And we have mathematical formulas expressed as human readable English, which is, well, nice for lawyers, but not good for algorithms. If we have a way to actually get the formulas back out. There are many use cases that we can derive from that. And a key issue that crops up in many of the information extraction tasks in financial documents is rich text and lean knowledge bases, right? And entity linking is just one of them that highlights a lot of these issues. But again, I think that a key driver, and that's why I really thank you for the invitation here. This workshop is for this community to get together and really try to address these issues jointly, right? So there's a lot of work to be done there. So with that, thanks again for the invitation. Thanks for attending. Thanks for your time, and hope you stay connected.
Thank you. Thank you so much. This was a really interesting talk. I'm going to open up, let's take a couple of questions. We have a coffee break following, so we can eat into the coffee break a little bit. So I can take a couple of questions. You could post it on the chat box or on Rocket Chat on the AAAI website, or you could unmute yourself and ask your question.
I have a quick question. Thanks so much for the talk. It was very interesting. Regarding the extraction of information from the financial documents, how much do you see this as a learning problem versus an engineering problem? Specifically considering that a lot of the aspects that you mentioned, for example, like the relations about not exceeding or a particular information about the numerical values, they may not necessarily scale to a different problem or not be applicable in the context that you would want to explore the solution for a completely new problem. So would you characterize this more as an engineering extraction problem than, say, annotating the documents with a sequence-to-sequence model and doing a learning? What's your perspective on that?
That's a really good question. I think that there is like a lot of spectrum to the answer, right? So I think that kind of idea that I've sketched with the credit agreement covenants is a very focused information extraction method, right? That has some parts that are learned and can have some parts that are trained, but essentially it's not very easy to generalize it, right? On the other hand, it doesn't require a lot of training data because it relies on kind of knowledge-driven annotation or like dictionary annotation for many of the subtasks, right? On the other hand, if you do the sequence-to-sequence annotation, I think it works, right? So that is something that you can do, but it takes a lot more effort, right? So I think the sweet spot is somewhere in between, where you can come up with very easily applicable dictionary-based methods that enable you to kind of bootstrap your data set. And then once the data set is bootstrapped, meaning you have some kind of noisy annotations based in a dictionary, right? Then go to like a more full-fledged annotation regime and say, okay, now please correct these things, right? And then actually not just do this as a one-off thing up front, but really build this into the platform that the business users are actually using so that they can give feedback at the spot where they're using it, right? So in the long run, I think this needs to evolve into a kind of like a centralized platform that supports individual use cases where you can quickly stand up a new use case that is kind of imperfect, but already provides some value. But in the long run, then using training data generated during the use can improve the system. So that's kind of one way of seeing this, I guess.
Thank you. Maybe we can take one more question. Okay, maybe I'll go for this one. So, when for the first, Glove and Wörterbeck representations were popularized, one of the major strengths of those representations was the fact that they were encoding some sort of semantic compositionality and in some cases syntactic compositionality as well. Do you see any opportunity for doing something similar, but with the structural richness of the documents, so that some of these structural cues are encoded into these representations?
Yeah. So actually, I stopped my screen share already, but there is some work going on definitely to include these structural elements into the language models themselves, right? And really looking at like, we don't just have a sequence of tokens, but we let me actually like quickly share this again, because I think this is really nice work that that shows how you can get started with this. So let me see in the backup slides where there we have it. So here, the layout LM, for example, by Microsoft Research, that basically says, hey, we have XY coordinates on the document, right? And these documents, there is a meaning, right? It's not like just with a web page where everything is free flow. And if you feed in these XY coordinates, it really improves the results, right? And this is really just the very first step. It doesn't take into account the hierarchy of the documents. It doesn't take into account the hyperlinks of the documents, right? So I think all of these dimensions can actually be used to directly be encoded in something like a BERT or Roberta or whatever kind of pre-trained language model that you have, and really increase the accuracy. So yeah, there's a lot of potential there.
Very nice. Thank you so much. Okay, great. Well, thank you. This was a really great keynote that wrapped up a really great session. We'll be breaking briefly for